reality and virtual reality part 3. This is Dr. M. Prakash, Professor from Department of Mechanical Engineering. Now the part 1 and part 2, the contents covered in the module 1, introduction of augmented reality are augmented reality, definition, scope, history of augmented reality, examples are here. And in display content, multimodal display, visual display, projected displays are discussed. And visual perception, the recommended characteristics. And today's the part 3, the method of augmentation, ocularity and stereoscopy, focus, occlusion, resolution and refresh rate, field of view, viewpoint offset, brightness and contrast, distortion and aberrations, latency, and along with that ergonomics and social acceptance also going to be discussed. So what is method of augmentations? It's comparing the human visuality and other aspects, and it have two different types. One is optical see-through OST and video see-through VST. In optical system, user directly view the real world through the transparent display like smart glasses. Digital content is projected onto the transparent display. So we have a eye, and the content of the real world is also going to be see through that through the transparent display, and projected display is on the visual impact. It will having the connection between the visual display to the real world environment. The clear natural view of the real world can be visualized by using this optical see-through method, and no computer vision processing needed for the real world view. Very low latency for the real world because the human eye can see through the real world, so no need of any computer vision processing. The cons in that methods are limited brightness of virtual content, difficulty in occulting and real world objects, fixed focal plane for the virtual content can cause the urgent accommodation with a conflict in focuses. In the case of a video see-through VST method, in video systems, the cameras capture the real world, and this video feed is then processing and displayed on the opaque screens in front of the user eyes. The digital content is composited onto this video feed. So we have a camera and the content which is called as an HMD, head-mounted display, and make a comparison between them. It will not be a real world. Real world is already processed using the computer process. So the in between the real world processing also required for this. The main advantages of this video see-through methods are virtual content can be very bright, easier to occult real world objects, more control over the perceivable focal plane of the virtual objects, often used in VR headsets to provide the pass-through IR experiences. It also has some disadvantages. We have introduces latency, a potential for the lower focus length, and image quality is also being lower. So the example for usage of optical see-through and video see-through are Microsoft HoloLens, Magical Leap are used in optical see-through method, MetalCAD using the pass-through method. And we combining or discussing about ocularity and stereoscopy. Ocularity is the human vision systems in which we have a binocular visions. We are using the two eyes for the depth perception, and the field of view is going to be make a central and peripheral methods for accommodation. So the focus adjustment for the distance the people can be human can move towards the direction. The human ocularity is a biological and wider focal point of view or focal view and organic in nature. But digital ocularity is an optical system limited field of view and synthetic in nature. In the stereoscopy method, the depth perception through the disparity. So we have a left eye and right eye, but it have only one system in the stereo pair, and binocular disparity may be capable. It's a rendered parallax and visual stereo. How digital screen created 3D term. Understanding the foundation of natural and synthetic vision is taken care from the ocularity and stereoscope. And apart from the key characteristics of the vision perceptions are focus, occlusion, resolution, and research field of view. So here the retina and then optical system in the human brain is going to be taken care. The images whatever going to be taken, it's focused on the retinal surfaces, and we need to be represent that what it is really. When there is a mismatch of focal length between the virtual and real world causes the high strain, so vertipixel display. And in case of an occultism, the real object hiding the virtual ones and vice versa for the depth range. And the resolution and the refresh rate is the most important characteristics of visual perception. So when increasing the high amount of pixels, the screen door effect is going to be high. So low resolutions and the high resolutions are defined in nature for accuracy of the object to be projected. Then the refresh rate is increasing with high density displays for detailed fast update is given by the refresh rate. For smooth motion, crucial for regime and control. The field of view, how much of your vision is augmented, wider is better for the optical system. And viewpoint object, physical camera and the human eye, and the conflict between the virtual to the real world is called as point offsets. And brightness and contrast, you know well, eligibility under the varied real lighting condition, high peak brightness and dynamic range are crucial. And for distortion and latency, in detail of each one of them going to be studied in various um, uh, class hours. One is a focus focus on high importance in AR. Understanding the focus is a real thing for when it is nearer to the 0.2 meter and medium to 1 meter and far infinity. The focal mismatch is going to be taken in this place. When nearer to 0.2, dynamic focal plane adjustment is taken by. So ability of the display to match under physical focus depth. In a dynamic focus, there is a higher cognitive load produced efficient measure of the real world objects. In a fixed focus, that may be called as blurry in nature. In dynamic focus, there is a dynamic adjustment of the focus field to get the view in accurate manner. Focal depth mismatch, it is creating the poor depth, and focal depth alignment optical mismatch. So measure of focal specification and optimal focal designs and enhance the user experiences. And viewpoint object, and it's important in augmented reality is you must be aware about what is a viewpoint object. So we have a real world optical path and had virtual path. Then there is a differences or offset between them because of the focal length. There is a mismatch. So eye center is a physical viewpoint and hand display is a virtual viewpoint. So there should not be any deviation or offset in that. When there is a no object, the stable object going to be there. When there is an offset, there is a shaking or trip. So user head movement is creating the optical offset or viewpoint offset, distortion of the images. So by improving the depth perception, reduce the motion sickness, stable virtual content enhances stable mapping. So software resendering is one among them. Is going to be make that it's a clear viewpoint offsets. And the brightness and contrast. So it should not be so bright, should not be so low in value. So 100 nits and 2000 nits. So nits are cent cubic diameter per meter square. Its peak brightness versus the base brightness. So everyone going to be make use of the smartphone displays. So most of them are nowadays using the adjustment mode depend upon the ambient environment. So 1000 to 1 lakh of contrasting nature can be created between the brightness and darkness area. So the focus on clarity is legibility and clear information is generated. Because of this, very much important to making the very good contrast and then brightness in nature. The importance for realism and immersion is poor contrast creating the vast out of lens, high contrast creating the realism, deep flakes and seamless integration between them. So we need to be know about the exactness about the objects. And another characteristics is a field of view FOV, and it is important in AR. The horizontal FOE and vertical FOE. The angular extension is going to be taken. The pixels per degree PPD is measure of an FOE. Sometimes it may be called as a narrow FOE and wide FOE. It is reduce the information availability. Wide FOE increase the information related to that. The human being can able to visualize the narrow FOE, get to know about the objects which are all under the focal viewpoint. So the most important aspects of the field of view is the environment and user health factors, the safety, user health, motion sickness, and user comfort, and improved obstacle reduction, everything. So each one characteristics is very much important to reduce that human impact of increase the cognitive ability to interpreting the object along with the real world environment. And other important characteristics are latency. The latency is called as the total system time from the user movement to the updated visual overlay or the over display. So the ultra low latency is optimal one, 5 milliseconds. Low latency is 10 milliseconds, and noticeable latency is 50 milliseconds. Poor experience 100 milliseconds. When there is a low latency, it's creating the very good infrastructural ability, high cognitive low. So latency must be very low. High latency creating the poor plan, low latency creating the optimal plan. So the important things of latency is going to be known in various application motions. Another one is called perpetual cues in augmented reality. Perpetual cues are sensory signals enough user to seamlessly integrate the virtual content into the real world content. So pictorial cues and stereoscopic cues. So pictorial cue creating that occlusion and relative size are smaller or bigger. So the perpetual cues are creating the 3D visualization in high definition manner. Okay, and the resolution. Everyone know about this bad called as resolution, high resolution camera and low resolution camera. High resolution giving the highest impact of those. So the perpetual consistency between them is creating between high resolution to the high refresh rate and creating the playable and solid virtual objects. It's a horizontal pixel and vertical pixel. PPT, pixel per degree is 40 and 3200. So in the horizontal direction, it will be creating more amount of resolution manner. Okay. So motion blender and high resolution picture. The motion clearly known to the movement of the objects, not in the objects to be moved simultaneously. And distortion and aberration. Distortion is a perpetual cues and sensory signals that allow seamless integration of virtual and real content, but optical system introduce the complex distortion and aberrations. So this is the mode of distortion creating the blurriness of the objects. And finally we move on to that economic status of an augmented reality. It purely depends upon the objects as well as the people movement along with the augmented reality environment. So the physical ergonomics fitting the device to the user, head mounted display, adjustable straps and optical ring, everything is being there to creating the economical value. And the posture and movement is creating the neutral neck spine motions, arms power zone. These are all the good in nature, it's the bad observations. And visual interface designs prioritize the essential information, avoid the occlusion, cognitive load going to be less in nature, and clear legibly text. When interaction and attention is created by initiative gestures and haptic feedback and voice commands. The user-centric design and adjustability one among the factors for the economics. It depends upon the customized manner. Everyone can be able to reach the zone of an augmented reality. And another aspect of social acceptance of AI. So in which it's creating the clear benefits and task performance and economic value. By utilizing the AR, all aspects of a benefit going to be taken in social relevance. So AR in the community going to be taken and perceived and utility value, trust and privacy ethics, and usability, design aesthetic, and social influence of cultural movement. So the surveillance and fear factor going to be reduced because of an utilization of AR systems. So this is a real world exercise. So you can able to get back from the QR implementation. So these are the references followed for all the 3 parts, and thank you for your patient listening, and get you know about introduction about the augmented reality from the part 1, part 2 and part 3. Thank you all.